Which means that in some sense, pull requests are code reviews. So opening the pull request means that you expect anybody on the team who might be affected by that code to at least take a look. And one of the many safeguards at Google is that there's no code that gets checked in unless at least one human being on the team has looked it over, even if all they say is looks good to me, no problem, right? We actually think that it is a very good practice that anytime you have a pull request in your team, at least one, and ideally more than one person, will take a look, make some sort of comment. Again, even if the comment is just looks good to me, right? That says, I have actually scanned the code you want to check in. I know that you've run the test, so there's no issue with test passing. I know there's no merge conflicts because you're rebased. But the code itself, I think your changes, I don't smell anything unusual. If that's not the case, if people do find problems, they can leave comments in the pull request. You can modify the pull request in place as you address people's comments. You can actually close the pull request without merging. So basically, I'm going to withdraw it. Let me go back and work on my code some more, implement your suggestions, and then you could reopen a new pull request. And again, now you might have to rebase again, because in the time it takes you to address their comments, maybe master has changed again. But basically, this is how GitHub works. There's a great talk that I'm sure you can find online, whose title is something like How GitHub Uses GitHub to Develop GitHub. And basically, this is what they do. They don't have formal code reviews within GitHub pretty much at all. Their code review is the pull request. And the benefit of doing it that way is that any individual code review act is pretty compact, because the branch per feature philosophy says, even if the feature is pretty small, do it on its own branch and contain all the code changes that are related to that feature. That makes it easier for your colleagues to look at it. What they're looking at is a very limited set of stuff. Right? So this is actually a very good way to do development, and we certainly think it works well. Historically, has worked very well for 169 projects. So what are your goals? Don't merge red. Right? It's fine if you have red, meaning red failing tests. If they're in your branch, that's normal, right? That's what branches are for. It's to give you a place to get it right. But you should never be doing a pull request where the thing that you're trying to merge is failing some tests, because that means that now master is going to fail those tests as well. And that probably means that you may have had to change tests on your branch also. And like I said, our suggestion is your secondary goal is to keep master always safe for deployment. So that gives you sort of an invariant. Okay? So in industry, you'll find different ways of dealing with branches. Branch per feature is certainly one of the most common ways, not the only way. We have found it to work well in scenarios like this, and there is no feature too small to deserve its own branch. Really no feature too small. It's free to create a branch, and it's just as free to delete the branch if it really was a trivial change. So what does that look like in terms of the overall project workflow, which you're now starting to get familiar with? So some of these projects started from or had to create a golden repo. That's the repo that we, the CS169 organization, are the owners of. The reason for that is so that when you all are gone to greener pastures, we can keep these projects and have the next crop of students work on them. So you have then forked that golden repo to your team's repo. Our recommendation is that the individual team developers clone the repo. There's an alternative to this, by the way, which is that if you have n developers, each developer could have their own fork. We don't particularly think that that adds any value for a team of size 6, which is what most of these teams are. In particular, if you've got multiple copies of the repo, and now you're doing pull requests across the repos, it's just more things to keep in sync. And I think if you're running a team pretty tightly and your team is in communication, everybody's sort of on the same page about what's going on, it is a much lower development overhead to do things at the level of branches within a common origin repo than it is for each team member to have their own fork of it on GitHub. Again, it's not that you can't do that, but we found that it adds complexity, it adds management overhead for you, and it's not clear that it really adds a lot of value. Each developer will then have their own clone of the repo, but there is one GitHub origin copy of the repo. And ideally, you're all going to be doing great branch per feature, nice clean development, doing pull requests to get your, oops, what did I do? Doing pull requests to get your features merged back into master with good test coverage. And because you're all using Travis and Code Climate, once you get them properly set up, which The first time you do it is a little tricky, but once it's set up, it's really nice because it kind of just works. So you get the nice little green badges saying that your build is passing. By the way, of course, there's no real build step for Ruby apps, right? You don't have to compile them. So what we're using Travis for is to actually run all of your tests. So the badge would be more accurate if it said regression passing or tests passing. We got you hooked up to Code Climate, so you can see whether the code you wrote is maintainable. I think they've actually renamed the badge now. It used to say Code Climate and then a GPA. Now it says maintainability and a GPA. And I think maintainability is actually a better description of what the badge is measuring. And then test coverage. A quick clarification about the test coverage thing, because I know some people had trouble setting it up. I'll get to that in a moment. You're deploying to Heroku. Your customer is using the Heroku app and giving you feedback. Everybody is happy. And by the end of the semester, if not earlier, our hope is that you'll be able to do, or you will have done, one or more pull requests from your team's repo back to the golden repo. So those features become a permanent part of the artifact that future groups of students are going to work on, right? So, my kind of, if you had a bright line test of like, do you have a successful project? If you do one significant PR back to the golden repo and that becomes part of a permanent code base, that is success, right? That in an 8-week, 4 iterations, you've been able to make a permanent contribution to a piece of software is actually kind of a big deal. And it's a piece of software that, remember, has to be able to survive and be maintained long after we can no longer get a hold of any of you, right? So to be able to say, I contributed something that's become part of a piece of software that, and now it has a life of its own separate from me having contributed, that's a really big deal. That's a great thing to be able to say when you're talking about interesting software positions. A clarification, because there was some confusion around where this coverage badge comes from. So Travis CI is designed to be a very general environment for doing builds and tests. It's language agnostic, which is why it has that whole travis.yml file where you have to tell it in great detail what to do. What comes out of Travis CI is thumbs up or thumbs down. Because it is language independent, you have to write your Travis scripts or use the one that we provided as an example so that at the end of the day, Travis tells you either everything works or something didn't work. And in particular, Travis itself can't do things like measuring test coverage because the way you do that is very specific to a particular language. So the recommended setup that we provided a file for, what it's actually doing is Code Climate has provided a test reporting coverage tool that can be part of your Travis run. And what our example file tries to do is right before Travis begins running all of your Cucumber and RSpec tests, it starts up the test coverage reporter, and after each set of tests is run, it records how much coverage those tests gave. At the end, it merges the coverage results from Cucumber and RSpec, which is actually pretty important, right? Because your Cucumber test will get some coverage of the code. Ideally, your RSpec test will get more coverage into those places that are hard for Cucumber scenarios to reach. And you need to sort of merge that information to get sort of a single scalar of what fraction of C0 coverage does your code achieve. And that's where the badge comes from. So the badge is served from Code Climate, but Code Climate is providing a tool that Travis runs that collects the information, and at the end of your Travis run, it sends that information back to Code Climate right before it exits. Right? And that's what that token is used for. It's for Code Climate to allow Travis to pass that information back so that they can report it alongside your maintainability score. So that's how that all works. And I know it's a little bit of a pain to get all the moving parts set up, but this is one of those things that once you get it set up, you're rewarded manyfold because having constant monitoring of your test passage and your Code Climate is really, really good.